Okay, in the first part of this lesson on Introduction to Quadratics, we looked at how you could recognize a quadratic relation from the equation, the graph, or the table of values. What we want to do in this second part of it is identify the key features of the graph of a quadratic relation. So our focus here on just being able to identify, and you can see the list here, the vertex, the concavity, the maximum or minimum value, the x-intercepts, the y-intercepts, the axis of symmetry, and what are called symmetric points. Being able to identify those and possibly find those and understand what all of those terms mean. And where we're going to get eventually is we want to be able to connect these features of a parabola to what the equation of a parabola looks like, or what the table of values that represents a parabola looks like. And to sort of put this in context, we'll go back to talking about linear relations like we did at the start of the lesson. If we've got the equation, the graph, and the table of a linear relation, we can find some key features of the linear relation from these three things. So if we focus in on the equation here, y equals negative 2x plus 4, we know just from this equation that the slope of our line here is negative 2, and the y-intercept is 4. Okay, so that tells us that our graph over here, our y-intercept, is equal to 4. And our slope, sort of our change in y, or change in x, so our slope or our rise and our run, we have to be going down to and going over 1. So we can make these connections between sort of these features of the graph, like the slope is a feature of the graph, but it tells us something about the equation, or the equation tells us something about the graph. And if we zoom in here on like another feature of our graph might be, we also have an x-intercept over here. Our x-intercept is equal to 2. These also kind of show up in our table, right? From our table, we know that our y-intercept occurs where x is equal to 0. So in our table, if we go to where x is equal to 0, we get that our y-intercept is equal to 4. Similarly, our x-intercept over here occurs where y is equal to 0. If we go in our table to where y is equal to 0, we get that our x-intercept right here is equal to 2. Okay. So that's kind of where we're going with this stuff eventually, after we have a better understanding of the equations of quadratic relations. For now, though, we're just going to focus in on these key features, or these key parts of the graph of a parabola. So the first one we're going to look at here is what is called the vertex. And the vertex is the point where the parabola changes direction. Our parabola either starts off at the top and comes down and turns around and goes back up again, or it starts at the bottom, goes up, turns around, and comes back down again. And this point where our parabola turns around is called our vertex. So our vertex is right here, and that parabola, and in this parabola, our vertex is right here. And it's a point that's on our parabola, so we can just read the coordinates here off the graph. For the red parabola here, the coordinates of our vertex are -1, -4. And for the blue parabola, the coordinates of our vertex are 1 and 2. And the vertex is probably the most important point to be able to identify on a parabola. We're going to spend a lot of time talking about what you can learn from the vertex. So our next point, you can see the big difference between our red parabola and our blue parabola is that sort of our red one starts at the top, goes down, and goes back up again. Our blue one starts at the bottom, goes up, and then goes back down. So they're sort of like mirror images of each other. This is a feature of parabolas that is called the concavity. So a parabola can be either concave up or concave down. So our red parabola here is concave up because it opens, that opening is in the upward direction, okay? Whereas our blue parabola over here is concave down because that opening is in the downward direction. related to the concavity, or whether it opens up or it opens down, a parabola can have a maximum value or a minimum value. And it's one or the other. It can't have both of them. So a maximum value would be the largest y value reached for the parabola. And this is only going to happen if our parabola is concave down. Okay, so we're looking here at the parabola over on the right. It has a maximum value because it is concave down. And the maximum value is reached right here at the vertex. And when we talk about it, like the highest point here is a y value of 2. So our maximum value is 2, okay? Because our vertex, which is at 1, 2, that maximum value is always going to be the y value of that vertex. Okay. In the parabola over here on the left, we don't have a maximum value. We have a minimum value. There's a lowest point on our parabola here, so this has a minimum value. And again, that minimum value is going to occur, it's going to be -4. Okay, because that's the lowest y value reached by our parabola. Our vertex here is -1, -4. Again, this minimum value is the same as the y value of our parabola, the y value of our vertex. So our maximum value or our minimum value is always the y coordinate of the vertex. All right. So parabolas also have what is called an axis of symmetry, and that's a vertical line that divides the parabola in half. And the left half is symmetrical or symmetric to the y half. So for our one parabola, this would be our axis of symmetry running right through the middle like that. And for our other parabola, our axis of symmetry would go through right like that. Okay? And this axis of symmetry always passes through the vertex, and it's a vertical line in every case. So for the one on the left here, our axis of symmetry is going to be, the equation of the axis of symmetry is x equals -1. It's a vertical line passing through -1. Over on the right, our axis of symmetry has the equation x equals +1. It's a vertical line that passes through +1. This also has a connection to the vertex, because remember our vertex here in our parabola on the left here is -1, -4. The x-coordinate of the vertex is the same as our axis of symmetry. Same thing in our other parabola over here. Our vertex is 1, 2. Again, this value, this x value here in the coordinates of our vertex is the same as this number here in the axis of symmetry. So it's related, let's just say, to the x coordinate of the vertex. Like linear equations, parabolas also have a y-intercept where the graph of our parabola crosses the y-axis. Here is our y-intercept. Coordinates of our y-intercept for this parabola, 0, -3. Okay. Remember, just like with a linear equation, the x-coordinate has to be 0 for a y-intercept. Okay. Same thing in our other one. Our y-intercept is right here where it crosses the y-axis. This is the point 0, 0. And again, notice the x-coordinate has to be 0. Okay, for a y-intercept. Same as linear relations. Parabolas also have an x-intercept, just like a linear relation does. It's a little bit more complicated here. x-intercept, of course, is the point or points where the parabola intersects the x-axis. It can have two x-intercepts, one x-intercept, or it could have no x-intercept. So for our parabola on the left here, our x-intercepts are going to occur here and here. Okay? The coordinates of these 2 points are -3, 0, and 1, 0. And notice, just like with the linear equation, the y-coordinate, y equals 0, for an x-intercept. For our parabola on the left here, our x-intercepts are here and here. These are the points 0, 0, and 2, 0. Again, at an x-intercept, y is equal to 0. So both of these parabolas have two x-intercepts. What do I mean by it can have one x-intercept or no x-intercepts? Well, I could draw a parabola kind of like this. The one on the left here comes down, turns around. Its vertex is right on the x-axis here. So there's only one x-intercept. The x-intercept here would be the point 3, 0. Okay, the x value where it meets that x-axis, and of course y is equal to 0. The one over here on the right has no x-intercepts because it comes down, the vertex is above the x-axis, so it turns around and it heads back up before it has a chance to intersect that x-axis. So finally, almost finally, parabolas also have what are known as symmetric points. So we know that in each of our parabolas, we have an axis of symmetry, which divides our parabola in half. And on either side of that axis of symmetry, we have corresponding points that are located, symmetric to each other. These points have the same y value as each other. So we've got a point here that is 2, 5, and a point here that is -4, 5. Same y value, just on opposite sides of the parabola. They also have to be the same distance from the axis of symmetry because, well, that's what symmetric means. So our point 2, 5 is a distance of 3 from the axis of symmetry. Our point -4, 5 is also a distance of 3. 1, 2, 3, 1, 2, 3. Okay. So looking at our graph here on the left, if we were to ask to find the symmetric point to the y-intercept, our y-intercept is right here. Our symmetric point would be over here. That point would be -2, -3. Okay. Our same y coordinate as our axis as our y-intercept, but a different x coordinate. Over on our graph to the right here, our y-intercept here is at 0, 0. Our symmetric point is here on the other side of our axis of symmetry. Okay. We know it's going to have the same y value, so it is going to be something 0 as well, and we can just read off the x value from here. It's going to be 2, 0. Okay. We can do this for the y-intercept, but we could do this for any points on our parabola. If we were to identify a point like this here at -1, -6, the symmetric point over here would have, we know it would have a y of -6, an x value of 3. Okay, those are symmetric points as well. Okay. So you want to be able to look at a graph and read off all of these sort of parts of a graph. You also want to be able to, if you're given some information about these parts of the graph, use them to figure out a little bit about what the parabola looks like. So here we are told that a parabola has a vertex of -2, 4, and it passes through the point 3, -1. And then we're asked a series of questions about these features of the parabola. We want to find the equation of the axis of symmetry, the concavity, the maximum or minimum value, and figure out the coordinates of another point that is on our parabola. To help you doing all of this, the best advice I have is try to make a little sketch of the parabola using the given information. So the information that we're given here is that there's a vertex at negative 2, 4. So I've got a xy plane here. I'll just go negative 2, 4. I'll say that this is my point, negative 2, 4 right here. Now that is going to, the other point that I'm given here is 3, negative 1. So I'll go on the other side. I'll say 3, negative 1 is going to be right about there. 3, negative 1. Okay, so those are the 2 points I'm given. Now I'm told that negative 2, 4 is the vertex of my parabola. So that means that that is where my parabola has to turn around. So it can do one of two things. It can start up at the top, come down and turn around and go back up. Okay. Now, if it does that, notice that it's not going to pass through this other point, 3, negative 1. Okay. There's no way I can draw that if it's coming down and going back up so that it's going to pass through that point. So I have to draw my parabola the other way. Let's just get rid of this. And I'm going to draw it so that the vertex is here, and then my parabola comes down like this and like this. Okay, now I can add to this sketch my axis of symmetry. I know it's going to divide my parabola right in half, and it's going to go through the vertex. Okay, this is my axis of symmetry. Okay, what is the equation of that line that I've just drawn? Well, we know it is going through the vertex. It's going to have an x coordinate. It's passing through an x coordinate of negative 2. So x equals negative 2. And because it matches up with the x coordinate of the vertex. Okay. Determine the concavity. Well, we discussed this a little bit, and we figured out that it could not be concave up. It had to be concave down. That is the only way that it was going to meet up with that, that other point that we had there. If it is concave down, we know that this is going to have a maximum value. And just looking at this graph, okay, we see that it starts at down low, goes up to a maximum value, and then turns around and falls down again. So our maximum value is going to occur right there. It is going to be a maximum value of 4. Remember that this is the y coordinate of our vertex. Right here is either our maximum value or our minimum value. Now, determine another point on the parabola. Well, we've got 2 points already. For our third point, we could figure out the point that is symmetric to this other point that we are given. We know that over here, there has to be another point symmetric to that point, 3, negative 1. It also has to have a y value of negative 1. I'm just going to put that in there because if it's symmetric, they have to have the same y value. Now I just need to figure out what the x value is. And I can do that by looking at how far away my 1 point is from my axis of symmetry. My axis of symmetry is over here at negative 2. This is a distance of 5, okay, from 3 down to negative 2, which means we have a distance of 5 on this side as well. So if our axis of symmetry is at negative 2 and we're going back another 5, this has to be negative 7. So our symmetric point there is negative 7, negative 1.